Unit 3, Day 3. Partial fractions. I kind of like this because this is new. This is different. It's not super hard. There's the official word for what we're going to do. It's fun. You didn't think you'd do this in a math class. We're going to decompose partial fractions. We're going to decompose a fraction. That's the official word for what we're going to do, decompose. The unofficial word, I made this up, is unadding. It sounds like subtracting, but it's not subtracting. We're going to take a fraction that somebody added some stuff to get to, and our job is going to be to, like, it's a game of Jeopardy. Like, well, where did that come from? What was the question that this is the answer? You're already
sounds like a lot of steps.
Hesitant, cautious, nervous.
It's either going to be really easy or obnoxiously.
It's not obnoxiously hard. It's definitely not really easy, though.
Tedious.
Maybe tedious, maybe. 5x minus 8 equals x over x minus 4. So our job is to figure out where did that come from. Like, that's the answer. What fractions would have been added to get that? Well, part of this you kind of already know.
I think I figured it out.
Like, what denominators would have had to have happened? Yeah, if this is my common denominator, one of them was x and one of them was x minus 4.
Was the top one 5 plus 2?
The top one's really hard to figure out.
Just the bottom's just x.
The bottom ones are easy. Like, just take your denominators. One of them had to be x. One of them had to be x minus 4. What we don't know are the numerators. So let's just call them a and b. Call them anything you want. Usually we go with a and b.
So, like, you're trying to figure out what times x.
If it's 4.
What times
Wait.
x minus 4.
2.
Yeah. That's kind of a lot of stuff, though. To, like, try to think of all that in your head of, well, yes, what times a times x minus 4 and b times x. That's a lot going on. Are we okay with setting it up for now?
It's definitely not.
So what I don't like is all the fraction business. So what I can do is multiply both sides by the common denominator to make it go away. And then I won't have any more fractions. Feels like cheating. I'm going to show this step that you probably won't show once you've done some of them, but people have such a hard time distributing x and x minus 4 to everybody and keeping up with who cancels that I'm going to show the step of distributing it to everybody. Again, once you've done it a couple times, you probably won't show this step. But so many people mess up at this step because they lose track of who cancels with what and who's left with what. Because there's a whole bunch of canceling going on, which is great because the fractions go away. But if you don't show this step, it's real easy to lose track of who got canceled and who's left with who. So on the left side, who gets to cancel? Both of them. The x's cancel, the x minus 4's cancel, and we're left with 5x minus 8. That will always happen on the left side because you're always going to be multiplying by that original denominator. So everything on the left, all the denominator on the left is going to go away. On the right, we're going to have to be a little more careful. Again, if you write out this step, it's not hard to see that for this one, the x's cancel. So that leaves a times x minus 4. And for the second term, the x minus 4's cancel. And we're left with b times x. So that's sort of, Crystal, that's sort of what you were trying to get at earlier when we first wrote this. You was trying to think out loud. Well, a times x minus 4 and b times x has to equal 5 minus x. You're right. That's a lot to just hold in your brain, though, to think about, because now I got two unknown. Well, I guess three, because I don't know what x is. I don't know what a is. I don't know what b is. But this is supposed to be true for every value of x. For any value of x I pick, this is supposed to work. So I get to pick any value of x that I like, but there are some good values of x and there are some not so good values of x. So we're going to pick good values. Why 0?
Because it's not existent.
Because it's simple. But more specifically, why is 0 is not always a good pick. It is a good pick for this one, though.
Positive.
So it'll cancel out.
You not just say positive.
It'll cancel out the b. So let's pick x equals 0, because that'll get rid of that term. So again, be careful. X is not always a good pick for this unit.
1.
You mean 0?
I'm sorry, yeah, 0 is not always a good pick for this unit. It happens to be for this problem because, let's plug in 0 for x, because it wipes out the b term. So that leaves me with negative 8 equals negative 4a. A equals 2. And remember, big picture, so I'm zooming out here. I'm trying to find, I knew the denominators right away. Now I'm trying to find those numerators. I got one of them. X is 2. Well, let's pick another value of x. Well, we picked one value that made this term go away. Let's pick a value that makes this term go away. So let's pick 4. So who cares what it does to the rest of the equation? What we're concerned with is making some of this stuff go away. So again, great pick for x, because we wiped out that term. So let's see. Oh, a is 2. I guess we know that now, but it doesn't matter because 4 minus 4 is 0. There are more complicated versions of this where you have to carry that a equals 2, but we're not doing them. Let's see. 20 minus 8 would be 12. So b is 3. Olivia.
Every time we do this, are we going to use an x that totally cancels out one of them?
Yes. When we say pick a good value of x, that's what we mean. Pick a value of x that will wipe out one of the terms. Because it just makes things easier. You can pick any value you want, but man, if you pick the right ones, it sure makes this easier. Alright, so now I know what a and b are. Look back up at the beginning. A was over x, so 2 over x. B was over x minus 4, so 3 over x minus 4. So there's my answer. So you see, it's kind of a Jeopardy game. We give you the answer and you give us the question. Rather than me giving you these fractions to add, I give you the answer and ask you where did they come from, and you provide the answer. Now, very few do what I'm about to suggest because it takes a while, but if you wanted to check your answer, how would you do it?
You multiply and find a common denominator. And then
Find a common denominator, add them together, and you should get right back where we
You just can't
started.
Scroll up the paper.
That's right. You know you did a lot when I've got to scroll back and forth.
Wait, is it? Can it be specific to? Like, could A be? Oh, well, I guess it doesn't matter.
Maybe what you're getting at is if you set this problem up differently,
The opposite way. It's,
if you put a over x minus 4 and b over x,
still the same thing.
your intermediate work's going to look a little different than your neighbor,
That's the same thing.
but you're going to end up with 2 over the x and 3 over the x minus 4. Which is a great question, because that means now if you're comparing with a friend and you just say, what'd you get for a? Well, they may have got something different. A better question is, what'd you get for over x? Or what number did you get for over x minus 4? Because they might have set up their a and b different than you did. So be careful, if you're comparing with somebody, make sure you set it up the same way when you're going to compare what your a's are. Let's do another one of those. X plus 3 over x squared minus 8x plus 15. Yeah.
Every word I just said is gone.
Oh, it's not that much harder.
You said a factor.
Kyle, what'd you say? We do want a factor. So let's see, x minus 5, x minus 3. I'm going to let you try this one on your own, but I do want us to set it up the same way so that if you are comparing with a friend, you'll at least be working the same kind of problem here. Which denominator do you want to list first? It doesn't matter, but somebody pick one.
The x plus minus 5.
Uh-oh, I heard several, but
Choose. You choose.
x minus 5 will go first for me, which is backwards and I have it in my notes, so I'll have to be very careful as I work this problem.
Is it always going to be plus?
Yes, good question. Is it always going to be plus? Well, we'll set it up with a plus. B might turn out to be negative, but that's fine. Set it up as plus. I mean, you can set it up as minus, but that would be kind of weird. Set it up as plus. So what would we do next?
You gotta do the bracket.
All right, I'm going to pause for a moment and see if you can take it the next couple steps. And then I'll come back and do the next couple steps. But that is a step that you could skip. If you cover that up and you think carefully about what we wrote, like the x, for this term, everything would cancel and you'd be left with x plus 3. For this term, the x minus 5s would cancel and you'd be left with x minus 3. For this term, the x minus 3s would cancel and you'd be left with x minus 5. So you don't have to show that step, but if you keep messing it up, then show the step, right? Like show enough work so you can get the problem right. What would be a good value of x?
3.
What else?
Negative 5 or 5.
Yeah, 3 and 5. So I'm going to pause again, and if you haven't finished it out, let x equal 3 and 5 and see what happens. I get b equals negative 3 and a equals 4. Questions on that? Now, I'm not done until I write my final answer. Kind of like Jeopardy, right? You can't just blurt out the answer. You have to put your answer in the form of a question. You got to put your answer in the form of a question. Yeah, what is 4 over x minus 5
I never understood that.
plus negative 3 over x minus 3?
Yeah, like it was just
Wait.
you just put what is. And then
What is?
Hold on. Wait. Why do you have?
Just kidding. You don't have to put the what is, but it does emphasize that this is kind of a Jeopardy type of question where we give you the answer, you got to do some work to undo it. This was the question. And again, if you really wanted to, you could get a common denominator, add those, and you should get back to what we started with. I want to set up number 4. So on the worksheet, Unit 3, Worksheet 3, let's look at number 4. So how many fractions am I going to have as part of my answer or question, however you want to phrase this? 3. So it works the same way. Obviously, it's a little more complicated. And it's about to get a lot more not a lot more complicated. So I'll multiply everybody by the denominator we started with. Now, in the interest of space, I'm not going to write all of that on each of those four terms. I'm going to be careful and distribute it. So on the left-hand side, let's see, everything would cancel, and I'd be left with 2x squared plus 1. That's the easy one. With the a term, what cancels? X. And so the other two are left.
So would you put a twice, or just a and then both those terms?
So it'd be a in both of those terms.
Plus
And then the b,
x.
again, you got to be careful because what you're used to doing when you cancel is, actually marking them out so the x's go away. The trouble with that is now it seems like the x is gone, but it's only gone for the first term. It's not gone for the second term. So be careful marking those things out. The x minus 1's cancel. That leaves x and x plus 1.
That's a nasty thing.
And then for the c term, the x plus 1's cancel. That leaves x and x minus 1. So how many values of x will I need to pick?
Should be
3, and what would they be?
negative 1, 1, and 0.
Negative 1, 1, and 0. And again, it looks very complicated, but when you plug in x equals negative 1, this goes away, right? Because if one of the factors is 0, that wipes out the whole thing. X equals negative 1. That goes to 0, so that goes away. And you'd only be left with the c term.
So couldn't you just do negative 1 and 0? Because b and c would just, if x is 0.
If x is 0, it would wipe out these two terms, but it wouldn't wipe out the a term, which is good because you need to know what a is.
Oh, never mind.
So let's see, 2 plus 1 is 3. A times negative 2 times 0 plus b times negative 1 times 0 plus c times negative 1 times negative 2. So that kind of looks bad, but 0, 0. Oh, that's kind of a yucky one. Oh well.
Wait, how did you... Never mind.
So 3 equals 2c. C equals 3 halves.
Did you plug them?
So plug in x equals 1. We get 3 equals a times 0 times 2. B times 1 times 2. C times 1 times 0. Again, it always looks like it's, all these variables, but if you pick the right x's, stuff goes away. And I'll let you finish it from
Wait a
there.
second, that's for demos.
So yes, number 4 is more complicated, but it's still the same process.
The x plus 1 plus minus 1,
Mm-hmm.
does that mean that those two will always be the same?
No. No, that just happened to work out that way. So we unadded the fraction. And again, this really shows up in the importance of it is in calculus, because we want to do something with this in calculus, but we can't do it when it's like that. We have to break it up, and it's a whole lot easier to do the thing we want to do in calculus with these three little fractions compared to this one big ugly fraction. And what the thing is the integral, but that's a long time from now. But that's why we need this algebra skill, is because when we get to this, we don't want to do that with this. We want to do it with those three little pieces rather than this one big chunk of stuff.
Could you go down?
What's that? So this is another place where it's super important to be neat. I mean, it's always important to be neat when you're doing math, but the more complicated the problem and the more involved it is, you need to have a system to be neat. Don't be going all over the page. You know, x equals -1's over here, and then up here, upside down, you've got x equals 1, and then on the back on some scratch paper, x equals 0. Like, have it neat and organized so you can keep up with your work. And maybe more importantly, so I can keep up with your work. All right, that leaves you with just 6 more of those and then one review question. And I remember to post the answers today. Look at me.
Which one?